For 18 years, he'd been the master of controlled destruction, understanding explosive dynamics, shockwave propagation, and structural collapse with expertise that impressed civil engineers. Frank seemed like every other experienced blaster who'd found purpose in precision demolition work, until blast system failures threatened catastrophic urban destruction, and everyone discovered that the demolition worker had designed the explosive safety protocols they were using. Franklin Joseph Kowalczyk was 75 years old, with gray hair that remained thick despite decades of exposure to construction dust, and intense brown eyes that could visualize shockwave patterns through complex urban environments as clearly as reading seismic charts. His calloused hands moved with practiced precision despite arthritis, placing explosive charges and calculating blast sequences with tolerances that ensured controlled demolition without affecting surrounding structures, while his voice carried the calm authority of someone who understood that controlled explosions involved forces that could level city blocks if safety procedures were compromised. Welcome to the Human Stories. Before we continue this incredible tale of hidden expertise and life-saving blast knowledge, tell me in the comments what city you're watching from today. And if you believe stories about quiet masters deserve to be heard, hit that subscribe button. Precision Demolition Services operated throughout the Chicago metropolitan area, where urban redevelopment required removing aging structures while protecting valuable buildings, infrastructure, and populations that surrounded demolition sites. The company specialized in controlled explosions that brought down everything from abandoned factories to obsolete highway overpasses, using blast engineering that had to account for shockwave propagation, debris control, and structural dynamics that affected entire neighborhoods. Frank had worked as senior blast engineer for 18 years, responsible for designing explosive sequences that demolished target structures while maintaining safety margins that protected surrounding areas from blast damage, flying debris, and structural vibrations that could affect foundations several blocks away. His demolitions involved calculations that accounted for building materials, weather conditions, and urban geology that influenced how explosive forces propagated through dense metropolitan environments. His approach to controlled demolition combined technical precision with comprehensive safety analysis, ensuring that explosive operations not only achieved demolition objectives, but also maintained protection standards that kept nearby residents, businesses, and infrastructure safe from forces that could cause catastrophic damage if not properly contained. Maria, the Riverside warehouse demolition will require shaped charges placed to direct the blast energy inward while preventing shockwave reflection from the adjacent office buildings. I'm calculating charge weights based on concrete density and steel frame distribution to ensure collapse occurs within the designated footprint. These technical consultations represented more than routine demolition planning. They were advanced blast engineering analyses that prevented accidents by ensuring explosive forces behaved predictably within safety parameters that protected urban environments from uncontrolled destruction. The demolition industry throughout the Midwest had come to respect Frank's expertise and innovation. His blast designs achieved demolition objectives while consistently exceeding safety performance. His shockwave calculations prevented damage that plagued projects managed by less experienced engineers, and his patient training helped younger demolition workers understand explosive physics well enough to recognize potential problems before they became dangerous. What impressed colleagues most was Frank's ability to solve blast engineering problems that stumped consulting experts, designing explosive sequences that achieved precise demolition results through innovative applications of shockwave physics that weren't commonly used in commercial demolition work. What none of them realized was that Dr. Frank Kowalczyk had spent 41 years developing explosive systems with destructive potential that made controlled demolition look like firecrackers by comparison. Frank lived alone in a comfortable house in suburban Oak Park, where he had chosen to retire to a location that provided tranquility while remaining close to the urban demolition projects that had defined his post-retirement career. The house was well maintained but unremarkable, furnished with pieces that reflected practical priorities rather than academic pretension. But the basement workshop revealed technical capabilities that exceeded demolition requirements. The walls displayed blast engineering diagrams and test documentation spanning over 40 years of explosive systems development. nuclear weapons design that had advanced America's strategic deterrent capabilities, mining explosives that had enabled large-scale resource extraction, and military ordnance that had shaped how the United States approached both offensive and defensive explosive applications. Bookshelves held technical references that most blast engineers would consider classified material: shockwave physics texts, explosive chemistry manuals, and blast effects research that Frank had contributed to during his career at national laboratories and defense contractors. Filing cabinets contained project documentation for explosive systems that had shaped how the United States approached everything from nuclear weapons testing to underground facility construction. And in a secured safe that seemed excessive for demolition work were credentials that would have transformed how Illinois' construction industry viewed their demolition worker: a PhD in applied physics from the University of Chicago, senior scientist credentials from Los Alamos National Laboratory, and consulting agreements with the Department of Energy that had shaped how the United States developed explosive technologies for both military and civilian applications. Dr. Franklin Joseph Kowalczyk, internationally recognized authority on shockwave physics and explosive systems design. His career had focused on developing nuclear weapons, military ordnance, and industrial explosives that required understanding blast effects far exceeding anything civilian demolition applications demanded. But equally important, he'd established safety protocols that prevented explosive accidents in environments where failure could cause mass casualties and environmental devastation. The work had taken Frank from theoretical research that advanced understanding of explosive physics to operational systems that enabled everything from nuclear deterrence to large-scale mining operations. His expertise had been crucial in developing the safety standards, blast prediction models, and containment procedures that governed how American industry and military used explosive technologies without endangering personnel who worked with systems capable of devastating destruction. His research had contributed to major advances in explosive safety, including the development of computer modeling systems that could predict blast effects in complex environments, containment technologies that could direct explosive forces with precision that minimized collateral damage, and training programs that taught workers to recognize and avoid explosive hazards that could cause instant death if safety procedures were violated. Retirement in 2006 was voluntary rather than mandatory. Frank had accumulated enough years in explosive research to retire with full pension while still young enough to pursue commercial work that didn't involve the security classifications and environmental liability that had characterized his government career. The demolition position wasn't about financial necessity. His government pension provided comfortable retirement income. It was about applying explosive knowledge to urban redevelopment rather than weapons development, using blast expertise to enable construction progress rather than advancing military capabilities, and continuing to work with explosive systems that challenged his technical abilities while contributing to civilian infrastructure improvement rather than national defense. But 41 years of explosive systems engineering expertise doesn't disappear because someone changes from weapons research to commercial demolition. And Frank's trained understanding continued monitoring blast safety issues that could affect both demolition operations and urban safety. Wednesday's September 11th started like every other demolition day. Frank arrived at the Riverside warehouse site at 6:30 a.m., reviewed final blast calculations for the controlled demolition scheduled for later that morning, and prepared for another day of applying explosive engineering that would remove obsolete industrial structures while protecting the urban environment that surrounded the demolition zone. The operation proceeded normally until 9:15 a.m., when Frank observed something during final pre-blast inspection that triggered 41 years of explosive safety experience. The shaped charges placed throughout the warehouse structure were exhibiting characteristics that weren't immediately dangerous, but matched signatures that Dr. Kowalczyk had studied during nuclear weapons testing, when explosive systems had developed instabilities that could cause unpredictable blast effects. The charge placement suggested that someone had modified the explosive configuration in ways that would cause shockwave patterns far exceeding the controlled demolition design.
Dr. Kovalchik had encountered similar modifications during weapons testing, when sabotage attempts had been made to cause explosive accidents that would appear to be engineering failures rather than deliberate attacks. Control Center, this is Frank on final inspection. I'm documenting explosive charge modifications that could cause uncontrolled blast effects. The charge configuration has been altered in ways that will create shockwave propagation exceeding our safety calculations. Frank, all explosive placement was completed according to your specifications. The blast sequence is ready for execution. Frank's explosive engineering training activated pattern recognition that had been developed through decades of investigating blast accidents that had caused everything from mining disasters to weapons testing casualties. Control Center, I'm observing charge modifications that indicate deliberate sabotage designed to cause catastrophic blast overpressure. If we proceed with detonation, the shock waves will exceed containment parameters and could cause structural damage throughout the surrounding neighborhood. Over the next 3 hours, Frank conducted systematic analysis using techniques learned during 41 years of explosive safety investigation. Blast effect modeling using computer software he maintained for precision calculations, shockwave prediction based on modified charge configurations, and damage assessment that evaluated potential hazards to surrounding buildings and populations. What he discovered was worse than routine demolition problems. The explosive modifications would cause blast effects designed to exceed safety margins by factors that could bring down multiple buildings beyond the demolition target, creating an urban disaster that would appear to be demolition engineering failure rather than deliberate terrorism. The sabotage was sophisticated enough to avoid detection through standard safety inspections, while ensuring catastrophic results that could affect several city blocks. Dr. Franklin Kovalchik was looking at evidence of explosive terrorism designed to weaponize controlled demolition. He needed to report his findings to appropriate authorities, but doing so would require explaining how a demolition worker possessed the expertise to conduct blast analysis that exceeded capabilities of most commercial explosive consultants. Dr. Kovalchik faced a choice that would define his impact on urban safety. He could file routine safety reports through standard demolition channels, hope that blast engineers would eventually identify similar problems through their own analysis, and risk allowing explosive terrorism to continue while bureaucratic processes slowly addressed threats that were actively being implemented. Or he could use 41 years of expertise in explosive systems to prevent blast disasters the way he'd been trained to do when similar threats emerged during his weapons research career. Dr. Kovalchik made his decision in approximately 8 seconds. He contacted the ATF's Explosives Division through professional networks that retained his security clearances, identified himself by credentials that carried immediate authority among explosive safety officials, and provided detailed analysis of sabotage evidence that indicated coordinated explosive terrorism targeting urban demolition operations. ATF Explosives Division, this is Dr. Frank Kovalchik, Explosive Systems Engineer. I'm documenting systematic sabotage of controlled demolition charges that indicate coordinated attacks designed to cause urban destruction through weaponized blast engineering. Dr. Kovalchik, this is Special Agent Robert Chen. Can you provide specific details about the explosive problems you've identified? Frank's voice carried the clinical precision that had characterized thousands of similar consultations during his government career. Agent Chen, I'm analyzing explosive charge modifications that will cause shockwave overpressure exceeding safety parameters by factors that could bring down multiple structures beyond the demolition target. The modifications are specifically designed to cause maximum urban destruction while appearing to be engineering failures. Sir, our demolition safety protocols are based on extensive testing and industry standards. How are you identifying explosive hazards that aren't apparent to standard safety inspections? Agent Chen, I'm using blast analysis techniques developed for nuclear weapons testing and military ordnance safety. The charge modifications I'm documenting will create shockwave patterns that exceed anything civilian demolition safety standards are designed to address. Within 6 hours, federal agents specializing in explosive terrorism were working with Frank to analyze evidence that revealed one of the most sophisticated urban attack plots in American history. The sabotage had affected controlled demolition operations throughout multiple cities, designed to cause mass destruction through explosive operations that communities trusted to be safe and controlled. Dr. Kovalchik, how did you identify the sabotage patterns when demolition safety engineers didn't detect deliberate tampering? Agent Chen asked during the investigation coordination. Frank looked around the Riverside warehouse site where enhanced explosive security measures were being implemented based on his blast analysis. Agent Chen, I've spent 41 years studying how explosive systems behave when modified beyond their design parameters. When you understand shockwave physics, deliberate sabotage becomes obvious through its effects on blast propagation and structural response. The investigation that followed exposed a domestic terrorism network that had been systematically compromising controlled demolition operations as part of a coordinated attack on American urban infrastructure. Frank's analysis had prevented what could have been the most devastating explosive terrorism event in civilian history, potentially saving hundreds of lives while preventing billions of dollars in urban destruction. The story remained largely within explosive industry and law enforcement publications, protecting both operational security and Frank's privacy, while ensuring that demolition safety protocols incorporated lessons learned from weapons research that could complement standard explosive safety procedures. Frank returned to his demolition duties, conducting controlled explosions with the same methodical precision that had characterized his pre-emergency work. But something had changed in his relationship with the explosive safety community and his understanding of how his expertise could continue serving urban protection. Frank, thank you for identifying the problems with our explosive charges, said project manager Sandra Rodriguez during the post-emergency analysis. The ATF investigators said your analysis probably prevented massive destruction throughout the entire neighborhood. Frank looked around the safely contained demolition site where enhanced blast monitoring now provided additional protection for surrounding communities. Frank, I've been working with explosive systems for most of my adult life. Whether it's nuclear weapons or controlled demolition, the physics stays the same. You have to understand how shock waves behave and what happens when explosive systems are modified beyond their design parameters. Were you really a weapons engineer? Frank smiled, adjusting his precision demolition hard hat that covered federal credentials he'd hoped never to need again. I've spent my career making sure explosive systems work predictably and safely. Now I get to apply that knowledge to urban redevelopment rather than weapons development. Dr. Kovalchik continued his demolition work until he was 82 years old, serving as informal explosive safety consultant for the ATF while maintaining the trusted demolition service that enabled Chicago's urban renewal without endangering the communities that surrounded construction sites.
Because he'd learned that the most effective explosive safety often comes from people whose expertise exceeds their visible roles, whose dedication continues regardless of official titles, and whose blast knowledge serves both individual projects and urban safety with equal commitment to ensuring that controlled destruction enhances rather than endangers the communities where people live, work, and raise families. The enhanced demolition security protocols that resulted from Frank's intervention became standard throughout American urban construction, demonstrating how expertise developed for weapons applications could be essential for protecting civilians who lived near controlled explosive operations that most people trusted to be safe but could cause catastrophic destruction if sabotaged by those who understood how to weaponize construction technology.
Frank's contribution to urban safety extended beyond preventing immediate terrorism to establishing monitoring systems that would enable early detection of future threats while maintaining the construction progress that enabled American cities to renew infrastructure and provide economic opportunities for growing populations.